right, so I wanted to talk a little bit about Lab 1. So first of all, when you made your graph, it should have been linear, and you should have plotted position in meters versus time. And you also need to make sure that when you do this, that you have a scatter graph and that you insert a linear curve fit. And the slope of this graph is your speed, okay? And what this slope tells you is that the position increases by 184 meters every second of time. So when you were doing this, you had to answer some questions about it being linear, yada, yada, yada. When I asked you for the slope, it should have been the slope from the linear fit. So if you did not give me that slope, if you just said 203 meters per second, because that's what I had in my video, that's not right, right? It's the slope. You don't need to calculate the slope. You have the slope. That's the purpose of doing a linear fit. So this person's was 184 meters per second. When you got ready to write this statement, you were literally just filling in the blanks. The quantity on the vertical axis is position. The slope was 184 meters, and the horizontal unit was seconds, and on the quantity on the horizontal axis is time. So you would just say the position goes up by 184 meters every 1 second of time. And then the y-intercept was given to you as well. So you would just write that down, and then you would just fill in the blanks. The position is whatever your y-intercept is in meters when time is 0. And then for your equation should always be equal to y equals mx plus b, right? So in this case, if you go back to your curve fit, it tells you x equals at plus b. So all you're going to do is say x equals and put in 184 meters per second times time plus 0.0235 meters, just like this person did on theirs. Let's get that, show that to you right there. That's it. And then, did the velocity change after collision? Yes. So when you look at your graph, you see the slope was not as much, right? So after the collision was about right here, look, the slope is 130 versus the slope, which was close to 202, okay, to begin with. So it was 202 to begin with and 130 afterwards. So you need to make sure that you are using the data. So the other thing is, I want units on your slopes and your y-intercepts. Okay, I want units in your equations. And, you know, the reason why we do these linear fits is because we want to make sure that we know what the slope is, because that is the speed or the velocity on a position time graph. Slope is speed or velocity. So that's what this graph was all about. Just a couple of comments about other things. Your homework and WebAssign, if you ever have questions, shoot me an email. Okay, if you have problems with the labs, I try to grade the labs during the week. If I see somebody is really screwing up, I will make comments and then send you a message, an email telling you, hey, I requested you to revise your lab so that you can make 100. I don't want you to do poorly on it. So don't wait till the last minute to do your labs. And then that was basically what you had to do this week. So next week you're going to be having 3 assignments. You'll have a discussion, a lab, and a homework worksheet. And we'll talk about that in a different audio file.